Right now, in university physics departments all over the world, there are people who could tell you something about time that would change how you look at every day you have left. They will not do it. Not because it is secret. It is printed in textbooks. It has been sitting in the open since before your grandparents were born, and you could download the papers tonight. They will not do it because 100 years ago the profession settled on a way of describing it that makes the largest claim in modern physics sound like a filing issue. A discovery got called a problem, and once you call something a problem, everybody knows what to do with it. Fix it, quietly, and stop mentioning it. So what exactly did they find? And what does it take to make an entire discipline lower its voice for a century? Settle in, subscribe if you haven't already, and stick around, because tonight we're going to take those equations apart in plain language and then go looking for the reason almost nobody ever says out loud what they mean. By the end, you will know both. Let's begin. Part 1. What you believe about time. You've been lied to about time, not by a single person, and not on purpose. There is no villain in this story, which is part of what makes it so strange. The lie was assembled by accumulation, over about 118 years, by a profession that knew exactly what its own equations were saying and decided. Conference after conference, textbook after textbook, semester after semester, that there was no particularly urgent reason to say it out loud in words a normal person could understand. And here is the lie, as precisely as I can put it. You believe that time passes. You believe the past is gone, finished, closed, no longer anywhere. You believe the future has not happened yet, that it is genuinely open, unwritten, waiting. And you believe the present is a thin moving edge, the leading surface where reality is being manufactured moment by moment, and that you are riding along on that edge, carried forward whether you like it or not. You feel yourself moving through time the way a boat moves through water. You can almost feel the current. None of that is in the physics. I want to be careful about that sentence because it is the sentence the entire next 2 hours is going to be built on, and it is easy to hear it as something softer than what I mean. I do not mean that the flow of time is unproven. I do not mean it is controversial or debated or awaiting further evidence. I mean something much flatter and much harder to argue with. I mean that when you write down the equations that describe how the universe actually behaves, the ones that work, the ones we have tested to more decimal places than almost anything else in the history of measurement, the ones that are running in the satellite that told your phone where you were this morning, there is no term in them that does the job you think time does. There is no quantity in the mathematics that moves. There is no variable that marks which moment is the real one. There is nothing anywhere in the structure that distinguishes the instant you're sitting in right now from the instant you were sitting in an hour ago, or the one you will be sitting in tomorrow morning. And this has been true since 1908. That is not a recent development. That is not something a paper announced last year. It has been sitting in the open, in print, in the language of the field, since before either of your grandparents was born. The people who write the equations have known for over a century that the universe does not work the way you think it does, and they have simply not said it in a voice loud enough or plain enough to reach you. So I want to be honest with you about the shape of this video right at the start, because there are 2 questions here, and only one of them is hard. The first question is, what do the equations actually say? That one has an answer, and you're going to have it well before we are halfway through. It has a name, it has a history, it has a very specific mathematical content, and by the time we are done you will understand it well enough to explain it to someone else at a kitchen table. That part is not a mystery. It is just a thing that was never taught to you. The second question is the hard one, and it is the one I want you to hold on to as we go, because I am not going to answer it until the very end. The second question is, why has nobody ever told you? And before we go one step further, I want to close a door, because if I do not close it now, it will sit in the back of your head for the next 2 hours and ruin everything. This is not a conspiracy. Nothing in this video is classified. Nothing here was suppressed, redacted, hidden in a vault, or quietly removed from a journal. Every single paper I am going to describe is public. Some of them are free to download right now. The lecture that starts this whole story has been in print for over a century in half a dozen languages. The letter is archived. The equation is in graduate textbooks. Nobody has ever been silenced, and no one ever will be, and if you take one thing away from the next 2 hours, I would like it to be that. Which, and I want you to sit with this for a second, makes the whole thing considerably worse rather than better. Because a conspiracy would be reassuring. A conspiracy would mean there were people who understood exactly how big this was, who felt the full weight of it, and who made a deliberate decision about what to do with it. A conspiracy has adults in it. What actually happened is that a discipline found something enormous, and then, without ever holding a meeting, without ever taking a vote, without any one person ever deciding it, collectively agreed to describe it in the smallest available words. To call a discovery a difficulty, to call a result a problem, to put a technical claim in a private letter, and then, for 70 years, remember the letter as a lovely piece of writing rather than as a statement about how the universe is built. The thing was never hidden from you. It was just never said to you in a way that would land. So here is what we are going to do. We are going to go back to the room where the first sentence was said, and we are going to find out what happened to the man who said it. We are going to walk through the actual physics slowly enough that you can follow every step of it, including the one step that almost nobody outside the field is ever shown. We are going to look at a letter that a dying man wrote to a grieving family and read it the way it was actually meant. We are going to look at an equation written in 1967 that attempts to describe the entire universe, all of it, everything that exists and which came out of the mathematics with no time in it whatsoever, and at what the profession did next, which is the single most revealing thing in this whole story. Then we are going to look at the three people who did say it out loud, plainly, in public, and at exactly what it cost each of them. One of them lost his reputation. One of them was politely thanked and then ignored for 50 years. One of them lost 30 years of his professional life in a farmhouse in the English countryside. And then, at the end, we are going to come back to that second question, and I am going to give you the honest answer to why nobody told you. It is not the answer you're expecting. It is not the one I was expecting either. It starts in a lecture hall in Germany in the autumn of 1908 with a mathematician who has 4 months to live and does not know it. Part 2. The Man with 4 months left. The date is the 21st of September, 1908. The city is Cologne. The occasion is the 80th Assembly of German Natural Scientists and Physicians, which is not a physics conference in the way we would think of one now. It is a general science meeting, a few days of talks that move city to city each year, attended by chemists and physiologists and geologists and engineers, as well as physicists. The room is broad and mixed, and most of the people in it are not going to follow anything technical. The man about to speak is Hermann Minkowski. He is 44 years old. He is one of the finest mathematicians in Europe, and he has a personal connection to the theory he's about to talk about that most of the room does not know. He taught Albert Einstein mathematics at the Zurich Polytechnic, and he had not been impressed. The remark that has come down to us in various forms is that Einstein was a lazy dog who never bothered about mathematics at all, which is a wonderful thing to know about this moment, because Minkowski has spent the last 3 years doing nothing but working out the mathematical structure hiding inside his lazy dog's paper. Imagine the room. It is autumn in the Rhineland. The light in a hall like this in 1908 is gaslight and grey daylight through high windows. There are rows of men in dark coats with notebooks on their knees. There is the low shuffle of a large audience settling. Somewhere at the back, people are still coming in. Minkowski takes the front of the room, and the first words out of his mouth are not an introduction, or a summary of the literature, or a note about his methods. He goes straight in. He says that the views of space and time which he wishes to lay before them have sprung from the soil of experimental physics, and that in that lies their strength. He says they are radical. And then he says the sentence. Henceforth, space by itself and time by itself are doomed to fade away into mere shadows. Only a kind of union of the two will preserve an independent reality. And the room does not react. Why would it? Nothing in the room has changed. The light is the same, the notebooks are the same. Somebody at the back coughs. A few people write the sentence down because it sounds like the kind of thing you write down, and Minkowski moves on into the geometry, and the assembly breaks for the afternoon and everybody goes to dinner. I want to be precise about what he had just said, because 118 years of quotation have sanded it down into something that sounds like a nice line about how everything is connected, and it is not that at all. It is a technical claim, and it is enormous. Space by itself is not a thing. That is the claim. Not, space is more complicated than we thought. Not, space and time influence each other. Space on its own, as an independently existing arena, does not exist. Neither does time on its own. What exists is a single four-dimensional structure. 3 directions we call spatial, and one we call temporal, welded together into one geometric object. And the business of dividing that object into space, right now, and time, flowing forward, is not something the universe does. It is something each observer imposes on it from the inside. Here is the image I want you to hold, because we are going to come back to it more than once. Think of a globe. A globe has a north pole and a south pole and an equator, and a grid of lines running across it, and those lines are real in the sense that you can point to them and navigate by them and argue about them. But the planet does not have them. Nobody drilled a hole at the top. There is no line painted around the middle. The grid is a thing we laid over the shape so that we could talk about it, and if a different civilization had done it, they would have laid down a different grid, and neither grid would be the true one, because the shape underneath does not have a grid. Minkowski's claim is that now is a line on the globe. It is something you drew, and I want to give you the one piece of technical content that makes this more than a metaphor, because there is a very concrete payoff to welding space and time together, and it is the reason the idea survived. Once you have the four-dimensional structure, you can define a quantity, a kind of distance between two events, measured through the whole thing rather than through space alone or time alone, and every observer in the universe, no matter how fast they are moving or in what direction, calculates exactly the same value for it. Everyone disagrees about how far apart two events were in space. Everyone disagrees about how far apart they were in time. Everybody, without exception, agrees on this one combined number. That is what Minkowski meant by an independent reality. He was not saying space and time are poetically intertwined. He was saying, here is the thing that is actually there, and here is the arithmetic that proves it, and the two familiar things you thought were real are just the two shadows this one casts on your particular wall. There is a small, delicious irony in what happened next. Einstein initially did not like it. He's on record dismissing Minkowski's geometrical reformulation as superfluous learnedness, mathematical showing off dressed up on top of a perfectly clear physical idea. It took him years to come around, and when he finally built general relativity, the theory that made him the most famous scientist who has ever lived, he could not have done it without Minkowski's four-dimensional structure. The framework he had waved away turned out to be the only floor strong enough to stand on, and here is a second image, gentler, that will not seem disturbing at all yet. Think of a book, a thick one, a novel, 1,000 pages, bound, sitting closed on a shelf. All the pages exist. They exist right now, simultaneously in the same object. Page 1 is not more real than page 900. The book does not become more real as you read it. Nothing is added to it by being read. Hold on to that. It is a completely harmless image at the moment. We are going to come back to it near the end of this video, and by then it will not be harmless at all. Now. 4 months after that lecture, in January of 1909, Hermann Minkowski's appendix ruptured. He died. He was 44 years old. He never saw what happened to the idea. He never saw it become the standard geometric language of relativity. Never saw it taught in every physics department on Earth. Never saw his four-dimensional structure become so completely absorbed into the field that people would eventually stop noticing it was a claim at all. The lecture was published the following year, posthumously, by Teubner in Leipzig, as a small separate volume. A man who had 4 months left spent one of them saying the largest sentence of his life to a room that did not particularly react, and then he was gone. There is a coincidence attached to that year that I find genuinely difficult to shake. In the same year, 1908, in Cambridge, a philosopher named John McTaggart published a paper called The Unreality of Time. He was not a physicist. He knew nothing about Minkowski's work, and Minkowski knew nothing about his. He was working purely from logic, and he argued that the very idea of a moving present generates a contradiction, that the way we talk about past, present, and future cannot be made consistent, and therefore that the passage of time is not a feature of reality. Two men, one country apart, in the same 12 months, from two completely different directions, arriving at the same suspicion about the same thing, neither cited the other, neither, as far as anyone can tell, ever knew. That is the moment the road forks. Everything else in this video happens on the far side of it. But a sentence in a lecture hall, however good the sentence is not evidence. It is a claim about what the mathematics means, and mathematics can be interpreted, and interpretations can be argued about. What makes this story more than a 100-year-old rhetorical flourish is that the geometry Minkowski was describing has consequences. Real ones, checkable ones, things that happen in the physical world whether anyone believes in them or not. And the first of those consequences is something you have walked past on the street, without noticing, probably today. Part 3. The crack you can walk past. Special relativity, the theory Minkowski was giving a shape to, rests on two statements. Einstein put them down in 1905 and everything else falls out of them. The first one is reasonable and most people accept it the moment they hear it. The laws of physics are the same for everybody who is not accelerating. If you are on a smooth train moving at a constant speed with the blinds down, there is no experiment you can perform inside the carriage that will tell you whether you are moving or sitting still. Drop a ball, it falls straight down. Pour a coffee, it pours normally. There is no absolute standard of rest in the universe against which your motion could be measured. Fine. Most people have an intuition for that. The second statement is the one that breaks the world. The speed of light in a vacuum is the same for every observer, regardless of how that observer is moving. Think about how strange that is, because it is very strange, and the strangeness is doing all the work here. If I am standing still, and I throw a ball at 10 meters per second, and you are running toward me at 2 meters per second, the ball approaches you at 12. That is how speeds work. That is how speeds have always worked for every object any human being has ever interacted with. But if I shine a torch at you, the light approaches you at exactly the same speed, whether you're running toward me, running away from me, standing still, or travelling at 99% of the speed of light in either direction. The number does not change. It is not that we cannot measure the difference. There is no difference, and nobody wanted this. That is worth saying, because it makes the acceptance meaningful. Through the 1800s, physicists assumed light travelled through an invisible medium filling all of space, the luminiferous ether, for the perfectly sensible reason that every other wave anyone had ever met needed something to wave in. Sound needs air, ripples need water. So in 1887, Albert Michelson and Edward Morley built an instrument of extraordinary delicacy, a stone slab floating in a bath of mercury so it could be turned smoothly without vibration, designed to detect the Earth's motion through that medium by comparing light beams sent in different directions. They expected a difference. They got nothing. They rebuilt it, refined it, and ran it again over the following years, and other groups repeated it with better and better equipment for the next century. Nothing. Every single time, the speed came back identical. The most famous null result in the history of science, and the reason we are forced into everything that follows, not because anybody found it appealing, but because the universe kept returning the same number no matter how it was asked. And once you accept that, and we have to accept it, because it has been measured to absurd precision for well over a century, then something has to give. And the thing that gives is your idea of at the same time. Here is why. Deciding whether two distant events happened simultaneously means, in practice, comparing signals from them. And if the speed of those signals is fixed and identical for everyone, but everyone is moving differently relative to the events, then when you do the arithmetic carefully, different observers get different answers about which one happened first. Not different guesses, different correct answers. There is no third observer, no umpire, no cosmic reference frame you could appeal to who would settle it, because the first statement, the reasonable one, says no such reference frame exists. Two people can disagree about whether two things happened at the same moment, and both of them can be right, and the disagreement is not about their instruments or their perception, or the delay in the light reaching them. It is about the geometry of the world. And it is worth pausing on that last point, because it is where almost everybody's first objection lands, and it is a good objection. You might reasonably think, well, of course they disagree. Light takes time to travel, so if I am further away I see it later. That is true, and it is not what is happening here. That effect is trivial and everybody corrects for it. Both observers in this scenario know exactly where the events happened and exactly how long the light took to reach them, and they do the subtraction, and they work out when the events actually occurred. And after all of that, having corrected for everything, they still disagree. The disagreement is not in the seeing, it is in the being. Now, the size of the disagreement, there is a formula for it, and you do not need to be able to manipulate it to feel it, because it has only 3 ingredients. The offset between two observers' versions of now grows with their relative speed, and it grows with the distance to the event, and it shrinks, enormously, with the square of the speed of light. That last term is why you have never noticed any of this. The speed of light squared is a number with 17 digits in front of the decimal point. Divide anything by that, and it essentially vanishes. Two people passing each other in a corridor have versions of now that differ at the far end of the corridor by something in the region of 1 part in a billion of a second. Nothing in your life will ever be affected by it. But look at the other term, distance. That one has no ceiling. In 1989, Roger Penrose put this in a book called The Emperor's New Mind, in a thought experiment that has been known ever since as the Andromeda Paradox, and it is the single most effective demonstration of this that anybody has come up with. So, imagine an ordinary street. It does not matter which one. Make it one you know. It is late afternoon, and the light is going flat and orange the way it does. There is traffic somewhere behind you, and the smell of somebody's cooking coming out of a window. You're walking north at the completely unremarkable speed of a person walking, about 1.5 meters every second, and a stranger is walking south towards you at about the same speed. Neither of you is in a hurry. Neither of you is thinking about anything in particular. You pass each other. It takes about a second. Your shoulders come within 0.5 meter. You do not look up. Neither does she. There is no moment. Nothing at all happens. Now hold that second and pull your attention away from the street, up past the roofs, out past the atmosphere, out past the moon and the sun and the whole solar system, out past every star you have ever seen with your own eyes, and keep going, out across 2.5 million light-years of essentially empty space, until you arrive at the Andromeda Galaxy, 1 trillion stars turning slowly our nearest large neighbour. At the instant your shoulders passed each other on that street, your two definitions of right now, over there, were not the same. And because the distance term in that formula is 2.5 million light-years, the difference between them was not a billionth of a second. It was days. In your version of now, an event on a world in Andromeda has already happened. In hers, the woman who walked past you, whose sleeve you might have brushed, that event lies in the future and has not been decided. Penrose's own version of this is a fleet. In one pedestrian's present, an armada has already launched. In the others, the meeting where the launch was authorized has not yet taken place. Neither of you is wrong. That is the thing I need you to hold on to. This is not a puzzle with a hidden answer, where one of you turns out to have been mistaken. Relativity has no machinery for choosing between you. It does not contain a preferred slice. There is no extra term in the equations, no undiscovered parameter, no unused slot where a universal present could be inserted. The theory is not being coy. It simply has nothing in it that does that job. And I should be careful here, because the theory is not chaotic about this. It is very precisely selective. Relativity does have a rule about which events have a fixed order and which do not, and the rule is about whether light could get from one to the other. If a signal travelling at or below light speed could have left the first event and arrived at the second, then every observer in the universe agrees on their order without exception, because always precedes effect. You can never find a frame where you die before you are born, or where the glass shatters before it hits the floor. That structure is absolutely rigid, and it is called the light cone, and it is the reason relativity does not tear causality apart. But that leaves a region, everything too far away for light to have crossed in the time available. Physicists call it the elsewhere. And for every event in that region, the order is genuinely, permanently unfixed. There is no fact about whether it has happened. Andromeda, from where you are standing, is 2.5 million years of elsewhere in every direction. Almost the entire universe, at any given moment of your life, is sitting in a region where, has it happened yet, has no answer. You walked past each other. It took under a second. Neither of you noticed. And 2.5 million light-years away, days of history hung on which direction each of you happened to be facing. So we have a problem, and it is a very clean one. Two people, standing next to each other, hold two different versions of what exists right now. Both versions are equally valid, and the versions disagree about whether certain events have happened. Somebody, eventually, was going to sit down and work out what that actually implies. Two people did, separately, in different countries, a year apart, without knowing about each other. And what they concluded is the single most consequential thing in this entire video, and it is the one step that almost nobody outside a philosophy department is ever shown. Part 4. The Argument They Don't Teach. In 1966, a Dutch physicist named C.W. Rietdijk published a short paper arguing that special relativity taken at face value proves determinism. In 1967, an American philosopher at Harvard named Hilary Putnam published a paper called Time and Physical Geometry, arguing something very close to the same thing. Neither of them knew about the other. They were working in different countries, in different disciplines, in different languages of thought, and they arrived a year apart at the same conclusion because it is sitting right there in the mathematics waiting for anyone who bothers to look at it directly. The argument is now called the Reet-Dyke-Putnam argument, and I want to walk you through it one step at a time, because it is short, it uses nothing you have not already been told, and once you have seen it, you will not be able to unsee it. Step 1. Relativity says that observers moving at different speeds slice the universe into now, differently, and that no slice is privileged. We have established this. It is not in dispute. It is the reason satellites work. Step 2. Whatever exists, exists. If something is real, it is real regardless of whose point of view you take. A galaxy does not blink into existence because somebody started walking toward it. That would not be physics, it would be magic, and nobody in this argument is proposing it. Step 3. Now put those together. Take a walk on that street again. You're walking north and the woman is walking south, and in your slice of now, a certain event out at Andromeda has not happened. In her slice, at the same instant, on the same pavement, it has. Her now is exactly as valid as yours. That is step 1, and whatever exists in her now is really there. That is step 2, which means the event exists, but it is in your future, so your future exists. That is it. That is the whole argument. There is no additional machinery, no interpretive leap, no philosophical assumptions smuggled in at the end. Either the events in your future are already real, or one of those two steps is wrong. And to reject step 1, you have to reject the relativity of simultaneity, which means rejecting the theory that your phone's location service runs on. And to reject step 2, you have to say that what exists depends on how fast somebody's walking, which is not a claim anybody wants to defend. And the argument scales in a very unpleasant direction, which is the part that usually gets people. It does not just apply to Andromeda. The offset shrinks with distance, but it never reaches 0. Applied at the distance of the next street, it covers a few billionths of a second of your future. Applied at the distance of the sun, minutes. Applied across the galaxy, thousands of years. There is no distance at which the effect switches off, which means there is no natural boundary where already real stops. The structure is either sliced or it is whole, and relativity says it is whole. Which brings me to the sentence I want to plant in your head now, because we are going to come back to it much later and it is going to mean something different when we do. The version of you that woke up this morning still exists, not as a memory, as geometry. In the four-dimensional structure the equations describe, the body that opened its eyes a few hours ago is sitting at a specific set of coordinates in the same way that Paris sits at a specific set of coordinates on a globe. Paris is not no longer there, because you are in your kitchen. It is there, and you are not looking at it. That is the entire difference. You are not, in the language of the physics, past that version of yourself. You are elsewhere in the structure from it, and the reason you cannot see it is not that it has ceased to exist. It is that you are standing inside the object and can only ever look along one particular direction through it. Hold on to that sentence, not as memory, as geometry. Now, I can hear the reasonable objection forming because I had it too. This is a lot of weight to put on a 100-year-old theory. What if the theory is subtly wrong? So let me lay out the ledger, because it is genuinely absurd. In 1938, Herbert Ives and G.R. Stilwell, and Ives, wonderfully, spent his career trying to disprove relativity, measured time dilation directly in a laboratory by looking at light emitted from fast-moving hydrogen atoms. It was there, in the amount predicted. In 1971, Joseph Haefel and Richard Keating put cesium atomic clocks on ordinary commercial airliners and flew them around the world, once eastward and once westward, and then compared them to clocks that had stayed on the ground at the United States Naval Observatory. The clocks disagreed. They disagreed by tens and hundreds of nanoseconds, in different directions depending on which way the plane had flown, and the disagreements matched the predictions. Somebody bought seats for a suitcase full of clocks and used a scheduled passenger flight to demonstrate that time is not universal. Cosmic ray particles called muons are created high in the atmosphere and decay, on average, in about 2 millionths of a second. At the speed they travel, That should let them cover a few hundred meters before they are gone. They arrive at sea level in enormous numbers. They do it every second of every day, over your head, right now, and the only reason they can is that their clocks run slow relative to yours. And the global positioning system applies a relativistic correction of about 38 microseconds per day to every satellite in the constellation. If you switch the correction off, position errors would accumulate at roughly 10 kilometers a day. The system would be worthless inside a morning. Here is the point of that ledger, and it is not the point people usually make with it. Everybody knows relativity is well tested. What is less often said is that every single one of those confirmations is a confirmation of the geometry that has the block inside it. There is no version of the theory that passes those tests and keeps a universal present. You cannot take the time dilation and leave the four-dimensional structure. They are the same statement. The satellite in your pocket is running on mathematics that says your future is already somewhere. And there is one more objection I should deal with here, because it is the one almost everyone reaches for, and it is a good one. Surely time obviously has a direction. Eggs break and do not unbreak. Cups smash and do not reassemble. Heat flows from hot to cold and never the other way. Everybody can see that. Is that not the passage of time right there in front of you? It is a direction. It is not a passage, and the distinction is the whole thing. The arrow you're describing is real and it is thermodynamic. Entropy, the number of ways the pieces of a system could be rearranged without you noticing, tends to increase, because there are overwhelmingly more disordered arrangements than ordered ones, and the universe started in a state of extraordinarily low entropy that it has been running down from ever since. That gives the four-dimensional structure a slope. One end is smooth and one end is rough, and that difference is why your memories are of one direction and not the other. But a slope is not a motion. A road that runs uphill from north to south is not moving. A book whose pages get progressively more crowded with ink is not being written while it sits on the shelf. The structure having a gradient tells you which way things are oriented inside it. It tells you nothing whatsoever about anything flowing. And here is the small piece of language that gives the whole game away. We say time passes at 1 second per second. Say that out loud. Every genuine rate in physics has different units above and below the line. Meters per second, degrees per minute, liters per hour, seconds per second cancels. It comes out to the number 1, which is a way of saying it measures nothing at all. The most ordinary, most obvious, most universally agreed upon fact about time turns out, when you look at it directly, to be an empty sentence. So, the geometry is confirmed to 14 decimal places. The argument from the geometry is 3 steps long and uses no exotic assumptions. It was found independently by 2 people in 2 disciplines within 12 months of each other 60 years ago. And it is not in the textbooks. I do not mean it has been removed. I mean that if you take an undergraduate physics degree at almost any university on Earth, you will learn the Lorentz transformations. You will learn to draw light cones. You will solve problems about the twin paradox and the pole in the barn. You will be shown the geometry in complete technical detail. And in most programs, at no point will anyone stand at the front of the room and say, and what this means is that tomorrow already exists. 60 years of leaving it out. Not by decree, by omission, term after term, by people who had themselves been taught by omission. And if you ever want to check this for yourself, and you can, find a physicist in private, somewhere they are not performing for an audience, and ask them straight out whether the future is, in the technical sense their equations imply, already there. Watch their face. We will come back to that. But the omission has a shape, and it has a start date, and it is not in 1966. To find it, we have to go back further, to a room in Paris, in the spring of 1922, where the man who wrote the theory was asked what it meant, and gave an answer that decided who was allowed to talk about time for the next 100 years. Part 5. The time of the philosophers does not exist. The 6th of April, 1922, Paris. A meeting of the French Philosophical Society, in a room that would have held perhaps 100 people, with the kind of formality that a European learned society had in that decade, announced papers, invited responses, a chairman, minutes taken. Einstein is 43 and has been, for about 2.5 years, the most famous scientist alive. In November 1919, the British eclipse expeditions had confirmed that starlight bends around the sun by the amount general relativity predicted, and the news had gone around the planet in a way that scientific news simply had not done before. The London Times had run it. So had the New York Times. A German physicist had overturned Newton 4 years after the end of a war in which Britain and Germany had killed 1 million of each other's young men, and the newspapers could not get enough of it. He is on a tour of Europe. He's being received like a head of state, and sitting across from him is Henri Bergson, who is 62, and who is at that moment probably the most famous living philosopher on the planet. This is not a footnote. Bergson filled lecture halls. When he lectured at Columbia University in New York in 1913, the crowds trying to get in caused the first traffic jam in Broadway's history. Whole rooms of people who had no professional interest in philosophy came to hear him talk about consciousness and memory and duration. Duration is his word, and it is what the argument is about. Bergson's central idea, la durée, is that lived time is not a line of separated instants. It is a continuous, indivisible flowing in which the past presses into the present, and the present is thick with anticipation of what is coming. When you hear a melody, he would say, you do not hear a sequence of unrelated notes, you hear a shape because the earlier notes are still in the current moment. That is duration. And Bergson's claim, made carefully and repeatedly, was that this is not a psychological curiosity layered on top of real time. This is the thing itself. This is what time is, and the mathematical time of physics, the t in the equations, the parameter, the coordinate, is an abstraction from it, a spatialized, flattened, measurable shadow of the real thing. And here is what I need to be scrupulous about, because it is routinely misreported. Bergson did not say relativity was wrong. He said the opposite. He accepted the theory. His position was that relativity is entirely correct about the time physicists measure and completely silent about the time human beings live, and that the silence matters, and that somebody had better attend to it, and that the somebody was going to have to be a philosopher. Einstein's reply is one of the most consequential things anybody has ever said in a room full of philosophers. He said that the time of the philosophers does not exist. Il n'y a donc pas un temps des philosophes. There is the time of the physicist, which is measurable and objective and appears in the equations, and there is psychological time, which is a fact about human beings and belongs to psychology. And between those two, he said, there is nothing. There is no third thing. There is no philosopher's time. Now notice what that does. Notice very carefully, because everything after this follows from it. It does not settle a scientific question. Nothing in that sentence is a claim about relativity. What it settles is a question of jurisdiction. From that evening forward, the question of what time is belongs to physics. The question of what time feels like is demoted to psychology, where it becomes a question about brains rather than about the world. And the sentence that connects the two, the sentence that says the one you feel is not a feature of the universe, is assigned to nobody at all. It is not a physics claim because physics has finished when it has written down the geometry. It is not a psychology claim because psychology does not do ontology. It falls straight down the gap between two departments, and it has been lying there ever since. That is the mechanism. That is how you get 100 years of silence without a single person ever deciding to be silent. You do not suppress the sentence. You simply arrange the world so that it is nobody's job to say it. And I want to be clear that the sentence did get said, occasionally, by serious people. It just got said in places where no ordinary person would ever encounter it. Hermann Weyl was one of the great mathematical physicists of the century, a man whose work underpins large parts of both relativity and quantum theory. In 1949, he put the block universe into print about as plainly as it has ever been put. The objective world, he wrote, simply is. It does not happen. Only to the gaze of my consciousness, crawling upward along the world line of my body, does a section of this world come to life as a fleeting image. That is the whole thing, in 2 sentences, from an unimpeachable source. The objective world simply is. It does not happen. And where did it appear? In an appendix to a technical monograph on the philosophy of mathematics and natural science, in a paragraph most physics students never read, written by a man who did not go on television because there was no television to go on. It was not a press conference. It was not a headline. It was a sentence in a book, filed correctly and left there. That is what the silence actually looks like from the inside, not censorship, correct filing. What happened to Bergson afterwards is its own small tragedy, and it belongs in the record. Later that same year he published a book, Duration and Simultaneity, trying to work out the relationship between his philosophy and relativity properly. and in it he got something technically wrong. He argued about the twin paradox, the thought experiment where one twin travels at high speed and returns younger than the one who stayed home, and he took a position that physicists could demonstrate was mistaken. The error was seized on. It was pointed at, repeatedly, for decades. It damaged his standing among scientists permanently, and it is the reason that Bergson, if he is remembered in physics at all today, is remembered as the philosopher who got relativity wrong, rather than as the man who asked the question relativity still cannot answer. He withdrew the book from later editions of his collected works. He never wrote about physics again. 5 years later, in 1927, Henry Bergson was awarded the Nobel Prize in Literature. So both men walked out of that room in Paris, and both men received Nobel Prizes, in different categories, for work on opposite sides of the same question. And that is a nice piece of symmetry, but it is not the reason I have taken you here. The reason is what happened in Stockholm 8 months after the debate, and it is the hardest single piece of evidence in this entire video. In November of 1922, Albert Einstein was awarded the Nobel Prize in Physics. Not for 1922, the 1921 prize had been withheld the previous year, because the committee could not agree, and it was awarded to him retroactively. And it was not for relativity. The citation reads, for his services to theoretical physics, and especially for his discovery of the law of the photoelectric effect. The photoelectric effect is genuinely important. It is one of the foundation stones of quantum mechanics, and it was one of the 4 papers Einstein published in his extraordinary year of 1905. But it is not why the world knew his name. It is not what the newspapers had been shouting about for 3 years. The single most important theory in 20th century physics, produced by the man standing there receiving the medal, was not what he was receiving the medal for. The presentation speech was given on the 10th of December, 1922, by Svante Arrhenius, the chairman of the Nobel Committee for Physics, and it is a public document that anybody can read. Arrhenius begins by acknowledging the obvious, that almost everything being said about Einstein in public concerns his theory of relativity, and then he explains in one sentence why the committee is steering around it. He says that the theory pertains essentially to epistemology, and has therefore been under lively debate in philosophical circles, and then he names a name. He says, the famous philosopher Bergson in Paris has challenged this theory, while other philosophers have acclaimed it wholeheartedly. Read that back and let it land properly. The most important theory of the 20th century was passed over for its own author's Nobel Prize, and the reason given, out loud, from a podium in Stockholm, in front of the King of Sweden, was a philosophical argument about the nature of time, an argument that had taken place in a room in Paris 8 months earlier, with the man in the audience, and which he had ended by saying that his opponent's entire subject did not exist. That is the earliest hard, dated, documented instance of the pattern this whole video is about. Not a conspiracy, not a suppression, something quieter and far more effective. The most prestigious institution in science looking directly at the part of relativity that touches what time actually is, deciding it was too contentious to put its name to, and quietly rooting around it. Everything you were taught about time in school came downstream of that decision. Not one of us was lied to individually. We were handed a curriculum that had already had the sentence taken out of it, by people who had themselves been handed a curriculum with the sentence taken out of it. Which leaves an obvious question hanging. Einstein clearly knew what his own theory implied. He had spent that evening in Paris refusing to let anyone else own the question. So what did he actually think it meant? Did he ever say? He did. Once. In writing. To a family in mourning 33 years later, 4 weeks before his own death. Part 6. The Letter to the Besso Family. Michel Besso met Albert Einstein in Zurich in 1896 at a musical evening. Einstein was 17. Besso was 23, an engineer, Italian by upbringing and Swiss by residence, and by every account a wildly discursive, generous, distractible man who read everything and finished very little. They were friends for 59 years. Besso is the person who put Ernst Mach's writing into Einstein's hands, and Mach's insistence that physics should only talk about what can actually be observed is arguably the single largest philosophical influence on the 1905 paper. Besso got Einstein the job at the patent office in Bern, and then took a job there himself, and the two of them walked home together most evenings for years, arguing. When Einstein finally wrote Special Relativity, he thanked exactly one person in it. There are no citations in that paper. There is no bibliography. There is one line of acknowledgement at the end to his friend and colleague Monsieur Besso for several valuable suggestions. Einstein said later that he could not have found a better sounding board in the whole of Europe, and it was not a purely intellectual friendship, which matters for what comes next. Besso was the one who was there for the human wreckage. He acted as an intermediary during the collapse of Einstein's first marriage, carrying messages, absorbing anger from both directions, trying to hold something together that was not going to hold. He and Einstein fell out over it more than once and repaired it more than once. In the same letter in which Einstein tells the family that the distinction between past, present and future is an illusion, he also says something that people almost never quote alongside it, that what he admired most about Michel was that he had managed to live for so many years with one woman in harmony, an undertaking, Einstein wrote, in which he himself had failed rather disgracefully. Twice. So this is not a physicist writing to a colleague's next of kin. This is a 76-year-old man, 4 weeks from the end, writing to the family of the person who had known him longest and forgiven him most, and saying, in the same breath, "You were better at being a person than I was, and also, he is not gone, and I can show you the mathematics." Michel Besso died on the 15th of March 1955 in Geneva. He was 81. 6 days later, on the 21st of March, Einstein wrote to his family, to Besso's sister and his son. He was 76 years old and living in Princeton, and he had an abdominal aortic aneurysm that his doctors knew about and that he had refused to have operated on. He had, at the time he sat down to write this letter, 28 days to live. Here is what he wrote. "Now he has departed from this strange world a little ahead of me. That signifies nothing. For those of us who believe in physics, the distinction between past, present and future is only a stubbornly persistent illusion." I want to read that again, slower, because in the 70 years since it was written, this has become one of the most quoted sentences in the popular literature on time, and the quoting has worn it almost completely smooth. "Now he has departed from this strange world a little ahead of me. That signifies nothing." For those of us who believe in physics, the distinction between past, present and future is only a stubbornly persistent illusion. In almost every place you will encounter that passage, it is presented as a lovely thing, a consoling thought, an old man reaching for poetry to comfort a family and finding a beautiful image. It gets printed on things, it turns up at funerals. Read the words again and ask yourself whether that is what is on the page. He does not say perhaps. He does not say I like to think. He does not say in some sense. He says for those of us who believe in physics, which is not a hedge. It is a specification of who this claim applies to and on what authority. He is not offering a metaphor. He is telling a grieving family what his theory says about their loss, and he is telling them that the thing they think has not happened in the way they think it has. Because look at what the block universe actually implies about Michel Besso. It does not say his life had meaning, or that he lives on in memory, or that energy is never destroyed, or any of the softer things that get said in that room. It says something much more specific and much stranger. It says that Besso has not been removed from existence. He has been removed from the region of the structure that Albert Einstein could currently access. From the standpoint of the four-dimensional object, Michel Besso is at his coordinates, in a flat in Geneva, alive, in 1950, arguing about physics, exactly as he always was, permanently. That set of coordinates is not blank. It is not erased. It is simply not where Einstein was standing. That is the claim. It is a technical claim about the geometry, from the author of the geometry, delivered in the last month of his life, to people in mourning, in private, in a letter that was never intended for publication at all. The most quoted sentence in the entire popular literature on the nature of time was written in a condolence note, and then the profession spent 70 years remembering it as a nice line. Now I promised you honesty, and honesty means giving you the strongest counter-argument as well, so here it is, and it comes from a serious place. Tim Maudlin is one of the most careful philosophers of physics working today, and he argues flatly that this whole industry of quotation is a misreading, that Einstein did not believe time is an illusion, that the letter is a consolation written by a dying man to a bereaved family and should be read as one, and that constructing a metaphysics out of it is exactly the kind of thing a philosopher of physics spends his career trying to stop people doing. Maudlin's own position is that the passage of time is real, that relativity does not force the block, and that a great deal of what gets said in videos like this one is overreach. That is not a fringe view, and I am not going to wave it away. If you want to hold on to the flow of time after tonight, Magdalene is where you go, and you will find that the position is defensible and defended. But there is a second document, and it is the reason I do not think the letter can be dismissed as consolation, and it almost never gets mentioned alongside it. The philosopher Rudolf Carnap knew Einstein at Princeton, and he recorded a conversation. Einstein told him that the problem of the now worried him seriously, that the experience of the now means something special for a human being, something essentially different from past and future, and that this important difference does not occur and cannot occur within physics. Carnap wrote that Einstein regarded this as a matter of painful but inevitable resignation. Painful, inevitable, resignation. That is not the vocabulary of a man offering a comforting image to a grieving family. That is the vocabulary of a man who has found something in his own equations that he cannot get out of them and cannot make peace with, and who has decided, after decades, to stop fighting it. He is not consoling anybody in that conversation. There is nobody there to console. It is just Einstein, in a room with a philosopher, admitting that the most vivid fact about being alive has no place in the theory he built, and that he does not expect this to change. So when he sits down 4 weeks before his death and writes that the distinction between past, present and future is only a stubbornly persistent illusion, I think we should take him at his word. He had been carrying that sentence for a very long time. He appears to have found somewhere to put it exactly once, and the place he found was a private letter to the family of the only person who had been listening to him since 1896. He died on the 18th of April, 1955, 4 weeks and a day after writing it. Let me stop here for a moment, because we have accumulated quite a lot, and I want to put it all on the table together before we go any further down, and we are about to go a very long way further down. Part 7. Everything we have so far. We are about halfway through, so let me lay the pieces out side by side. If you have drifted for a bit, this is where you can pick the thread back up, and if you have been with me the whole way, it is worth seeing the shape of what we have. We have a geometry. In 1908, a mathematician with 4 months to live stood up in Cologne and said that space alone and time alone are shadows, and that only the union of them is real. And he was not being poetic, he was reporting the mathematical structure of the theory. There is one 4-dimensional object, and the division of it into space now and time flowing is a grid you drew on a globe that has no lines on it. We have a consequence. Because light has the same speed for everyone, 2 people moving differently slice that structure into now differently, and no slice is privileged. 2 strangers passing on a pavement hold versions of the present that differ at the distance of Andromeda by days. Neither is wrong. The theory has no machinery for choosing. We have an argument. Reitdijk in 1966 and Putnam in 1967, independently, a year apart. If both slices are equally valid, and what exists in one exists, then the events in your future are already real. 3 steps. No exotic assumptions. Either that, or the theory that runs the satellite in your pocket is wrong in a way nobody has ever detected. We have the ledger. Time dilation in a laboratory in 1938. Atomic clocks on airliners in 1971. Muons falling on your head at this moment. 38 microseconds a day of correction on every satellite in the constellation. And every single one of those confirmations confirms the geometry that has the block inside it. We have a jurisdiction. Paris, 1922. There is no time of the philosophers. What time is goes to physics. What time feels like goes to psychology. And the sentence that connects them is assigned to nobody, and falls into the gap between 2 departments, and stays there. We have an institution behaving accordingly. Stockholm, 8 months later. The most important theory of the century passed over for its own author's Nobel Prize, with a philosophical dispute about the nature of time named from the podium as the reason. We have a private letter. A dying man telling a grieving family that the distinction between past, present and future is only a stubbornly persistent illusion, remembered, for 70 years, as poetry. And we have an omission. The argument that connects all of it is not in the standard undergraduate curriculum, not removed, just never put in, term after term by people who had themselves never been shown it. Now, I want to be honest about exactly what that pile establishes, because it is easy at this point in a video like this to feel like the case is closed, and it is not, quite. What it establishes is 2 things. First, that relativity has this content, that the block universe is not a fringe reading but what the geometry says when you stop hedging. And second, that the content is not being stated plainly to the public, and that this is a documented, dated pattern rather than a suspicion. What it does not establish is why. We have a shape without a cause. We can see the silence. We cannot yet see the reason for it, and I am not going to guess at it, because there is a much better source of evidence available and we have not touched it yet. So the question I asked you at the start is still sitting on the table, unanswered, and I want to say it out loud again so it does not quietly slip away while we are busy with the physics. Why has nobody ever told you? Not who hid it. We have settled that nobody hid it. Why has a plain, checkable, 118-year-old statement about the structure of reality never been said to you in a voice that would land? Keep that question. I will answer it at the end, and I will answer it properly. Because everything I have shown you so far comes out of one theory. Relativity is enormous, and it is spectacularly well tested, but it is one of the two great theories of the 20th century, and it is the older one, and it is the one that describes the very large. There is another one, quantum mechanics, the theory of the very small, and it is, if anything, tested even more precisely. And for 100 years, the deepest project in physics has been the attempt to put the two of them together into one description that covers everything, from a galaxy cluster down to an electron, to write down, in a single expression, the physics of the entire universe. Somebody tried. In 1967, somebody actually sat down and wrote that equation, and when it came out of the mathematics, there was something missing from it. Part 8. The equation with no time in it. In 1965, John Archibald Wheeler had a 2-hour layover at Raleigh-Durham Airport in North Carolina. Wheeler is one of the most important physicists of the 20th century, and one of the great namers of things. He is the man who popularized the term black hole, and coined wormhole, and quantum foam. He had worked with Bohr on nuclear fission. He supervised Richard Feynman's doctorate, and in the 1960s he was consumed by the problem that has consumed the field ever since. How do you put general relativity and quantum mechanics into the same sentence without one of them catching fire? He had a stopover, so he picked up a telephone in the terminal and called Bryce DeWitt, who was a physicist at the University of North Carolina in Chapel Hill, about 20 minutes away, and asked whether he would like to come and sit in an airport lounge for a couple of hours and talk about it. Picture it properly, because the setting is doing real work here. 1965, an American regional airport terminal. Rows of moulded plastic seats bolted to a rail, a departures board that clatters when it updates. Somewhere there is a coffee counter, and somewhere else somebody's being paged. Luggage carts, fluorescent light, the specific, forgettable, low-grade boredom of a place designed entirely for waiting. Two men sit down at a table. One of them has brought a piece of paper, and DeWitt did not need to prepare. He had been circling this for 16 years already. His doctorate at Harvard, finished in 1949 under Julian Schwinger, one of the architects of quantum electrodynamics, had been an attempt to quantize the gravitational field at a time when almost nobody thought that was a sensible thing to spend a career on. He had been carrying the problem around for as long as Wheeler had been carrying black holes. When the phone rang, he did not have to go and look anything up. He picked up the paper he already had. DeWitt arrived with the Hamilton-Jacobi equation of general relativity, an old and elegant reformulation of mechanics adapted to gravity. And over the next 2 hours, between flights, in that terminal, the two of them worked out the shape of what a quantum theory of the whole universe would have to look like. DeWitt went away and spent 2 more years doing the hard work, and on the 25th of August, 1967, it was published in the journal Physical Review, volume 160, pages 1113 through 1148, under the almost aggressively modest title Quantum Theory of Gravity. 1. The canonical theory. That paper contains what is now called the Wheeler-DeWitt equation, and I want to explain what it is trying to do before I tell you what came out, because the ambition is genuinely difficult to overstate. In ordinary quantum mechanics, you describe a system, an electron, an atom, a molecule, with something called a wave function, which encodes everything there is to know about it. And the Schrödinger equation tells you how that wave function changes as time goes by. Time appears in it explicitly. It is right there in the equation, as the parameter that everything else is described with respect to. The universe, in that picture, is a stage, and time is the thing that runs, and your electron does its business against that backdrop. The Wheeler-DeWitt equation asks, what if the system is everything? Not an electron in a laboratory in a building on a planet. Everything. All of space. All of matter. The geometry itself with nothing left over. What is the wave function of the universe, and what equation does it obey? And immediately you hit a problem that is not a technical problem but a conceptual one, and it is the hinge of this entire video, so I am going to take it slowly. When you write the Schrödinger equation for an atom, the time you use is time as measured by a clock outside the atom. Your clock. The laboratory's clock. The atom evolves with respect to something external to it. Now make the system the entire universe. Where is the clock? There is no outside. There is nothing external. Whatever clock you want to use is inside the thing you are describing. There is no laboratory bench that the universe is sitting on, no wall to hang a clock on, because the walls are part of the system too. And when you write the equations down carefully, with that constraint respected, the time term does not become difficult to calculate, or approximate, or ambiguous. It disappears. The Wheeler-DeWitt equation, in its compressed form, says that a certain mathematical operation, physicists call it the Hamiltonian constraint, performed on the quantum state of the universe, gives zero. That is the whole equation. An operator, acting on the state of everything that exists, equals nothing, and there is no time variable in it, not hidden, not implicit, not suppressed for convenience and recoverable later, absent, the most ambitious equation anybody has ever attempted to write, the one that tries to describe everything that exists, all at once, at the deepest level we have access to, does not contain the letter T. Read that again, because I think it is the single most extraordinary sentence in physics, and almost nobody outside the field has ever heard it. The mathematics, when you push it all the way down, does not contain the thing you have been calling time. Physicists have a name for what this equation describes. They call it the frozen formalism. And I want to be careful with that word because frozen makes people picture a universe where everything has stopped, which is not it at all. Stopping is something that happens in time, and there is no time here for anything to stop in. The better image is a photograph rather than a film, not a film that has been paused, a photograph which was never running. Except a single photograph is too small an image, because it suggests one moment picked out of many. What the equation actually gives you is closer to every photograph that could ever be taken of anything, existing together, with a number attached to each, and no reel, no projector, no order, and nothing anywhere that says which one you're in. Your sense that you're in one of them, and moving toward the next, is not described by the equation at all. The equation does not have a slot for it. Now, the obvious reaction is, that must be a mistake. Something has gone wrong in the derivation, or an approximation has been made badly, or somebody has dropped a term, and it is not. The absence is structural, and it comes from a property of general relativity that is right at its foundation. General relativity does not care what coordinates you use. That is not a convenience of the theory, it is the deepest thing about it. You can paint any coordinate grid you like onto space-time, stretch it, twist it, relabel it, and the physics is identical, because the physics is in the geometry and not in the labels, and crucially, that includes the time coordinate. You can slice space-time into moments in an infinite number of different ways, and general relativity has nothing to say about which slicing is correct, because from its point of view the question is meaningless. It is Minkowski's globe again, 60 years later, with the same answer. The lines are yours, not the world's. So when you take a theory that has no preferred time, and you quantize it, you turn it into a quantum theory, you get out a theory with no time. It could not have gone any other way. The absence in the equation is the mathematical restatement of the absence in the geometry. The two halves of this video are not two coincidences, they are the same fact, arriving twice from opposite ends of physics. There is a beautiful irony buried in how this was derived, and it deserves a mention. The framework that produces the timeless equation is called the ADM formalism, after Arnowit, Dieser and Misner, who developed it between about 1959 and 1962. And what ADM does is take four-dimensional space-time and cut it into a stack of three-dimensional slices of space, plus a rule for how the slices are stacked. It is a slicing procedure. It exists specifically to let you talk about the universe moment by moment. And when you push that slicing procedure all the way down and quantize it, What it hands back to you is the statement that there are no moments. The space that the resulting wave function lives in has a name too, and the name is worth knowing because it makes the picture vivid. It is called superspace, nothing to do with supersymmetry, and it is the space of every possible three-dimensional geometry that space could have, every possible shape of the universe. A single point in superspace is not a particle or a location. It is an entire possible arrangement of everything all at once, and the wave function of the universe assigns a number to each of them. That is what the equation describes. An enormous landscape of possible universe shapes, each with an amplitude attached, and absolutely nothing anywhere in the structure that says which one is now. Now honesty, because this is where a video like this could easily oversell. Nobody solves the full Wheeler-DeWitt equation. It is, in its complete form, mathematically monstrous, arguably not even well defined, and certainly not solvable with anything we currently know how to do. What researchers actually work with is called mini-superspace, which means throwing away almost all the degrees of freedom and keeping 2 or 3, and solving that instead. The most famous result of that program is the Hartle-Hawking no-boundary proposal of 1983, which is where the popular idea comes from that asking what happened before the Big Bang is like asking what lies south of the South Pole. That image, which many of you will have heard, is downstream of exactly this equation. So the equation is not a finished theory, and I will not pretend it is. It may not even survive. There are serious physicists who think the whole canonical approach is a dead end. But the timelessness is not an artifact of the approximations. It is the most robust feature of the entire framework. The thing that survives every simplification, that shows up no matter how you cut the problem, and that has resisted 60 years of concerted effort to get rid of it. And that last phrase is the important one, concerted effort to get rid of it. Because when this equation came out of the mathematics with no time in it, the physics community had a choice about what to call that. Part 9. They called it a problem. They called it the problem of time. I want you to sit with that for a second, because it is the single cleanest artifact in this entire story, and once you notice it, you will notice it everywhere. The most ambitious equation in the history of physics was written down, and what came out of it was that time, the thing every human being who has ever lived has organized their entire existence around, does not appear at the deepest level of the description. That is either the most important discovery of the 20th century or it is a bookkeeping error, and the profession looked at it and called it a problem, not a result, not a finding, not a discovery, a problem, which is to say, a difficulty, an obstacle, a thing standing between us and where we were trying to get to, something to be overcome. That word is not neutral, it carries an instruction inside it. If you tell a graduate student that their field contains a problem, they know exactly what they are supposed to do with it, and it is not to sit quietly and consider what it might be telling them. The naming did not conceal anything. It did something more efficient than concealment. It told 2 generations of the most capable people on Earth what attitude to take toward the finding before they had even looked at it, and they took it. There is now an entire subfield of theoretical physics whose sole purpose is to put time back into equations that came out without any. Christopher Isham's Standard Review, published in 1992, and still the paper most people are pointed at when they enter this area, is called Canonical Quantum Gravity and the Problem of Time. Karel Kuchar's survey from 1991 uses the same framing. Whole careers, whole conference series, whole shelves of the literature, all organized under a heading that describes the discomfort rather than the discovery. Generations of physicists have entered a field named after the trouble it caused them. Let me show you what those workarounds actually are, because they are serious physics done by serious people, and I do not want to be glib about them. The first family is called relational or internal time, and it is the most intuitive. The complaint is that there is no clock outside the universe. Fine, say the relationalists, then use a clock inside it. Pick some physical thing that changes, the overall volume of space, the value of some field, the position of a particle. Call that your clock, and then describe everything else not as changing with time, but as correlated with that thing. Instead of saying, the pendulum is here at 3 o'clock, you say, the pendulum is here when the hand is there. You never mention time at all. You only ever talk about how things line up with each other, and it works, mathematically. But notice what it costs. Time has stopped being a feature of the universe and become a relationship between 2 of its parts. It is not a stage anymore. It is a comparison. The second family is stranger, and, I think, more beautiful. In 1994, the mathematician Alain Connet and the physicist Carlo Rovelli proposed what they called the thermal time hypothesis, which says roughly this: the flow of time is not fundamental at all. It is generated by the thermodynamic state you happen to be sitting in. It comes from the fact that you are a large, warm, coarse object that keeps track of averages rather than details, that you do not know, and cannot know, the exact position of every particle around you. Time, on this proposal, is a byproduct of your ignorance, which has an implication that I find genuinely difficult to hold. If you knew everything, if there were nothing you had failed to track, there would be no flow, not you would perceive it differently. There would be no flow to perceive. The third family is called emergent or semi-classical time, and it is the most technically respectable and the least satisfying. It says, in the limit where gravity behaves classically, where the geometry is smooth and large and well behaved, you can recover something that looks and acts like a time parameter, and you can. The mathematics is solid. But it is an approximation, valid in a limit, and what it tells you is that time is what the timeless equations look like when you squint. Which is the answer, but it is not a rescue. Every one of these programs is legitimate. Real results have come out of all three, and I want you to notice something about all of them at once. Every single one is an answer to the question, how do we get time back? Not one of them is an answer to the question, what is the equation telling us? That is the shape of it. That is what a discipline looks like when it has found something it does not want. It does not lie. It does not suppress. It just quietly reframes a statement as an obstacle, and then funds 60 years of extremely intelligent people to remove the obstacle. And here is the part that seals it for me, the part that I think is the most honest and most human piece of evidence in this whole video, and it is not usually told at all. Bryce DeWitt did not want the equation. He never liked it. When he first wrote about it, he did not call it after himself. He called it the Einstein-Schrödinger equation, and he attributed it to Wheeler. Wheeler, meanwhile, called it the DeWitt equation, and gave the credit right back. In private, DeWitt referred to it as that damned equation. He held out on the naming for over 20 years, until a conference at Osgood Hill in 1988, when he finally gave up and accepted that everyone was going to call it the Wheeler-DeWitt equation, whether he liked it or not. And in 1997, 3 decades after publishing it, he said publicly that the equation should be confined to the dustbin of history. Think about the shape of that. One of the 2 men whose names are on the most radical equation ever written spent 20 years trying to get his name off it, and then said out loud that it belonged in the bin. Not because he had found an error in it. Nobody has found an error in it. Because of what it says. Now, there is one thread inside all of this that I have to come back to, because it is the closest anyone has come to actually testing the timeless picture, rather than arguing about it, and it is very elegant. In 1983, 2 physicists, Don Page and William Wouters, proposed a specific version of the relational idea. Their suggestion was that time emerges from entanglement. Split the universe into 2 parts. A small subsystem you designate as the clock, and everything else. Entangle them. Now, from outside the whole arrangement, nothing happens at all. The global state is completely static, exactly as the Wheeler-DeWitt equation demands. But an observer inside who is correlated with the clock, who asks, what is the rest of the universe like when the clock reads this? That observer sees a perfectly ordinary evolving world, static from outside, flowing from inside, both descriptions correct. For 30 years that was a suggestion on paper, and then, in October of 2013, a group at Italy's National Metrology Institute, Ekaterina Moreva, and colleagues, working with Vittorio Giovannetti and Lorenzo Maccone, built one. They made a toy universe out of 2 photons with entangled polarizations. One photon was designated the clock. The other photon was, in this miniature cosmos, everything else. And then they looked at it from both sides. An observer who measures the clock photon, and then asks about its partner, sees the partner evolving, changing, behaving exactly as though time were passing. An observer who stays outside and only measures global properties of the pair finds the whole thing completely static, with nothing changing at all. It is a demonstration, not a proof, and the paper says so. 2 photons on an optical bench is not a universe, but it answers the single most obvious objection anyone can raise against everything in this video, and it answers it physically rather than philosophically. If reality is fundamentally timeless, Why does anything seem to happen? Because from inside a static correlated structure, correlation is indistinguishable from change. They built one, and they looked at it from both sides, and that is exactly what they found. They called it a problem. They could have called it a result. And before we leave this, I owe you a genuine complication, because there is one obvious counterexample to everything I have just said, and it would be dishonest of me to walk past it. Carlo Rovelli, the same Rovelli who co-proposed thermal time, did say it in public, plainly. In 2017, he published a book called The Order of Time, written for general readers, in which he states about as directly as it can be stated that the difference between past and future is not written into the fundamental equations, that time as we experience it is a product of how coarsely we look at the world, and that the universe at its base has no clock in it. The book was a bestseller. It was translated into dozens of languages. People read it on trains. So it can be done. Somebody with the credentials did it, in plain language, in this century, and the sky did not fall. And here is what I find genuinely unsettling about that, and it is going to matter at the end. It changed nothing. The curriculum did not change. The framing did not change. The subfield is still called the problem of time. A first-rank physicist wrote a beautiful, accessible, widely read book saying the plain thing out loud, and the plain thing remains, 8 years later, something that most people encounter for the first time in a video like this one, at 1 a.m, from a stranger. Which suggests that the silence is not maintained by anyone in particular, and cannot be broken by anyone in particular. It is not a wall, it is more like a slope, a very slight, very consistent tilt in the whole landscape of how this gets talked about, that returns everything, eventually, to the small words. So try the experiment I mentioned earlier. Find a physicist in private, not at a lectern, not on a panel, and ask them whether the Wheeler-DeWitt equation really does not contain time. Ask whether the future is, in the technical sense their equations imply, already there. Watch their face. You will not get the answer the textbooks gave you. You will get a pause. You will get a very careful sentence. Somewhere in there you will get the word well. That pause is the subject of this video, and I still have not told you what causes it. But there were people who did not pause. There were people who said it flatly, in public, on the record, and did not soften it for anybody. There are 3 of them, and I want you to see exactly what happened to each one, because it is the closest thing we have to a measurement of what this costs. Part 10. What it costs to say it out loud. The first of them is Kurt Gödel, and to explain what he did in 1949 I have to explain what kind of mind we're dealing with. In 1931, at the age of 25, Gödel proved something that had been considered impossible even to formulate. Mathematics had spent 30 years trying to put itself on completely secure foundations, to find a set of rules from which every true mathematical statement could, in principle, be derived. Gödel proved that this cannot be done. In any formal system powerful enough to describe arithmetic, there are statements that are true and that the system cannot prove, and the system cannot prove its own consistency. That is the incompleteness theorem, and it did to mathematics roughly what relativity did to physics, except that it was worse, because it did not replace the foundations with better ones. It proved there are none. By the 1940s, Gödel was at the Institute for Advanced Study in Princeton, and he and Einstein had become close in a way that surprised everybody who saw it. They walked home together most days. Einstein told an economist friend near the end of his life that his own work no longer meant much to him, and that he came to the Institute merely to have the privilege of walking home with Gödel. In 1949, Einstein turned 70. The philosopher Paul Schilp was assembling a volume in his honour for the Library of Living Philosophers series, a collection of essays about a great thinker's work, with responses from the thinker himself. Gödel was invited to contribute. Now what do you give the man who invented general relativity for his 70th birthday? Gödel gave him a universe. He constructed an exact solution to the Einstein field equations, a real, valid, mathematically airtight description of a possible universe, with 3 properties. It rotates. It is homogeneous, meaning it looks the same everywhere. And it is stationary, meaning it does not expand or contract. And in a universe with those properties, something remarkable becomes possible. If you set off in the right direction and travelled far enough, you would arrive in your own past. Not through a wormhole, not through some exotic mechanism, just by going in a straight line for a very long way. Physicists call these closed time-like curves, and Gödel's solution was the first exact solution to the field equations ever found that contained them. He did not present it as a paradox to be resolved or a loophole to be plugged. He presented it as what the theory permits. And then he wrote a companion essay for the same volume, called A Remark about the Relationship between Relativity Theory and Idealistic Philosophy, in which he explained why he had built it. The argument is a logician's argument, and it is devastating in its simplicity. If the equations of general relativity permit universes in which there cannot possibly be an objective passage of time, because in such a universe every moment lies in its own future, and the whole notion collapses, then an objective passage of time cannot be a property those equations were ever describing. A theory does not have a feature that some of its solutions lack. Time, in the sense you mean when you use the word, was never what the theory was about. That is the birthday present. A logician handed the greatest physicist alive a mathematically perfect proof that his own theory does not contain time in the sense the human race means by the word. Now let me tell you what happened to it. The solution is in the textbooks. It is a standard exhibit in graduate general relativity courses, filed under exotic solutions and causality violation. It opened an entire technical literature: Tipler cylinders, rotating black holes, wormhole time machines, Stephen Hawking's chronology protection conjecture, decades of papers on whether the laws of physics conspire to prevent time travel. The interpretation, the argument Gödel actually cared about, the reason he built the thing in the first place, is almost never discussed. It is not refuted. It is not attacked. It is just not taught. Physics kept the present and lost the card. There is an honest caveat I owe you here. Our universe does not rotate at anything like the rate Gödel's solution requires. The constraint has been tightened enormously by measurements of the cosmic microwave background, and his universe needs a negative cosmological constant, while ours appears to have a positive one. Gödel's universe is not ours, and he knew that, and he even went and checked the astronomical data on galaxy rotations afterwards. It does not matter to his argument. He was never making a claim about what the sky contains. He was making a claim about what the theory permits, and about what that permission reveals concerning the theory's contents. The second man is Julian Barbour, and his story is the one I've been building toward all night. Barbour took his doctorate in the foundations of general relativity from the University of Cologne in 1968, the same city, exactly 60 years later, where Minkowski had said that space and time were doomed to fade into shadows. He had decided in his 20s what he was going to spend his life on, after reading Ernst Mach and coming across a remark by Paul Dirac suggesting that four-dimensional symmetry might have to be abandoned in quantum gravity. And then he made the decision that shaped everything. He worked out that the problem he wanted to solve was not going to produce publications at the rate an academic career requires. Foundational questions do not yield papers on a schedule. You can spend 6 years on one and have nothing to show, and a university will not keep you for that. So he did not take an academic position. Ever. He bought a house in the countryside north of Oxford, in a village called South Newington, and for roughly the next 30 years he supported his family by translating Russian scientific journals into English, papers on metallurgy, on plasma physics, on whatever came in, and he did his own work in the evenings and at weekends. Sit with that for a moment. 30 years. Not a sabbatical. Not a difficult stretch early on before things came good. 3 decades of translating other people's science, on deadline, for money, so that he could afford the house he did his real work in at night. No department, no salary for the actual work, no students, no colleagues down the corridor, no conference invitations for most of it. No reason whatsoever to believe that anybody would ever agree with him, and the position he was defending was one that the entire profession found frankly a bit embarrassing. A man on a farm with no affiliation, claiming that the universe is a static heap of moments. He was in his 60s when the book finally came out. Oxford University Press published The End of Time in 1999, and what is in it goes further than anything else in this video. Barbour's position is not the block universe. It is more radical. He argues that not only does time not flow, space-time itself is not fundamental. There is no four-dimensional object. What exists is a collection of possible instantaneous configurations of the universe, every possible arrangement of everything, existing without any sequence connecting them, without any order, without any next. He calls that collection Platonia, and then he answers the question you are already asking, which is, then why does anything feel like it is happening? Because some of those configurations contain records. He calls them time capsules, arrangements that include structures which look exactly like traces of a past, photographs, fossils, ripples, memories in a brain. Any version of you sitting inside such a configuration will find in your own head a coherent story running backwards and will experience that story as a history you have lived through. But nothing has run through it. There is no sequence. The story is a feature of the arrangement. It is not being told. Every version of you that exists complete, with its memories already in place, and none of them ever became any of the others. And I want to be precise about how the book was received, because the precise version is more interesting than the version where he was ignored. He was not ignored. The End of Time was reviewed widely and seriously, including in the British Journal for the Philosophy of Science. Physicists read it. Reviewers called it important. It sold, and then nothing happened. That is a specific fate, and it is not dismissal. Dismissal at least involves an argument. What Barber got was worse and much more common. He was admired and set aside. Everybody agreed the book was remarkable, and everybody went back to work on Monday, and the curriculum did not move a millimetre. 21 years later, he published a second book, The Janus Point, arguing that the universe has a single point of lowest complexity from which two arrows of time run outward in opposite directions, that what we call the beginning is a middle, and both halves think they're going forwards. That one was reviewed well too. And what happened to Barber is the closest thing this story has to a happy ending, which is a slightly bleak thing to say. The profession, without ever quite announcing it, moved toward him. Carlo Rovelli's entire research program rests on a compatible foundation. Shape dynamics, a genuine reformulation of general relativity that Barber developed with Enrique Gomes and Tim Kozlowski, is a live technical research direction with real published results. The man in the farmhouse turned out to be doing physics, and the field caught up quietly, without any moment where anyone said out loud that he had been right all along. And then there is the third man, and he went the other way, and I need you to hear this one because it is the reason I trust the rest of it. Lee Smolin was one of Barber's closest collaborators. They worked together for years on exactly the relational Machian foundations that shape dynamics grew out of. Smolin is a serious physicist, one of the founders of loop quantum gravity, and he knows this material from the inside as well as anybody alive. In 2013, he published a book called Time Reborn, arguing the precise opposite of everything Barber had spent 30 years in a farmhouse establishing. Time, Smolin says, is the one thing in physics that is fundamentally, irreducibly real. The block universe is a mathematical artifact, the result of taking a description and mistaking it for the thing described. Space might be emergent. The laws of physics themselves might evolve, but time is not going anywhere. He followed it in 2014 with a longer, more technical book co-written with the philosopher Roberto Mangabeira Unga. They stayed friends. That should be said, because otherwise this turns into a feud, and it was not one. And here is the part I want you to notice about Smolin's objection, because it is the most interesting thing in it. His complaint is not that the equations fail to say what I have told you they say. He does not dispute that. His complaint is that a universe without real time cannot explain why the laws are the particular laws they are, and cannot account for genuine novelty, for anything ever being new. His conclusion is that if the equations really do say this, then the equations are incomplete, which is, in its own backwards way, the strongest confirmation in this entire video that they say it. 3 people, 3 prices. Gödel, thanked politely and filed under exotic. Barber, 30 years in a farmhouse. And Smolin, who stayed inside the building, kept his position and said the opposite. Now, that is the history. Every bit of it is public, and none of it has ever been secret, and you have now heard essentially all of it. So let me stop talking about physicists and start talking about you. Part 11. The ones you lost are at their coordinates. There is somebody you have lost. I do not know who. Almost everybody listening to this has at least one, and if you are young enough that you do not yet, you will, and you already know it. So I am going to talk about this carefully, and I am going to be extremely precise about what the physics does and does not say, because this is the exact place where people go wrong in both directions. Under the block universe, the coordinates that person occupied are not blank. That is the claim. That is all of it. I want to state it at exactly that width, and not one word wider. Think about what it actually means. There is a set of coordinates in the 4-dimensional structure, a place, and a set of moments. where that person is having a conversation, where they are standing in a kitchen with the radio on, where they are 23 and have not met you yet, where they are laughing at something you would not have found funny. Those coordinates are part of the object. They are not a record of something that used to be there. They are not a memory of a region that has since been cleared. They are a region of the structure, and the structure is what exists. You're simply not standing at those coordinates. You're standing at these ones. Let me try to make that physical rather than abstract, and then I am going to take it away from you again, because it is important that I do both. So, think of a room you used to be in with them. A specific one. Not a special occasion, not a hospital, not a funeral, an ordinary afternoon. The kind you did not know you were going to want back. There is light coming in at a particular angle because it is a particular hour. There is the sound of something in another room. They are doing something completely unremarkable, reading, or looking for their keys, or complaining about something on the television, and you are there, and neither of you is paying any attention to the moment at all. Because why would you? Because there are going to be thousands more of them. That afternoon is at its coordinates, not preserved, not recorded, not remembered, at its coordinates, in the same four-dimensional structure you're in right now, in the same sense that Paris is somewhere while you're in your kitchen. The light is at that angle, the sound is in the other room, nobody is paying attention, it is not over, in the only sense of over that the mathematics contains, which is that nothing is ever removed from the object, and you cannot get there, and neither can they. I have to be that blunt, because this is where the whole thing is routinely abused, and I would rather disappoint you honestly than comfort you falsely. There is a very large body of writing, some of it well-meaning, some of it not, that takes exactly what I have just told you and turns it into something it is not. It circulates heavily in grief communities. Einstein's letter is its favourite document, and it gets quoted as if he were telling the Besso family that their father is somewhere reachable, that the connection persists, that something continues. Here is what relativity actually provides. It provides that the coordinates persist. That is the entire list. It does not provide access. It does not provide communication. It does not provide awareness across the structure. Nothing in the block is aware of any part of the block except from inside its own coordinates. It does not provide continuation, because the last coordinate is still the last coordinate. A structure that contains every moment of a life also contains its final one, and does not extend past it. And it does not provide reunion. There is no mechanism. There is not even the sketch of a mechanism. Relativity is a theory about geometry, and geometry has nothing to say about who is where or what anybody knows. The second thing people do with this is turn it into prophecy, and that one at least I can rule out with a piece of physics rather than with a warning. If the future is already real, the reasoning goes, then it must in principle be readable. Fatalism, precognition, the sense that everything is scripted and somebody somewhere might be able to see the script. It does not follow, and the reason is clean. In relativity, information travels within light cones. Nothing, no signal, no influence, no correlation you could exploit, gets from a later region of the structure to an earlier one. The block being real and the block being knowable are two entirely different claims, and only the first one has any support at all. The one structure that would change this is Gödel's. Closed time-like curves, a rotating universe, a path that comes back around to your own past. And we establish that our universe demonstrably is not that one. Your future is already there. Nothing can reach back from it. Both of those are true at once, and there is no tension between them. And the third thing people do is the film reel, and this one I want to spend a little time on, because it is the most seductive of the three and it fails in the most interesting way. The reasoning goes, a fixed four-dimensional structure containing every moment sounds an awful lot like a recording, and a recording implies a recorder. A film implies a projector, and behind the projector a projectionist. Therefore, simulation or design or an author of some kind. I understand the pull of that completely, and it fails at exactly one joint. A film reel needs something outside it to run it. The block does not. There is no external time in which the block unfolds. There cannot be, because time is a feature of the block, not a container for it. Which means there is no medium in which a projector could operate, no sequence in which a story could be told, no room anywhere for a mechanism. Nothing plays it. The structure is not being run. It is not being read. It simply is, entirely, without anything doing anything to it. And I want you to notice that this is a stranger claim than the simulation one. The simulation story is, at bottom, a comforting story. It puts somebody in charge, it gives the shape a reason for being that shape. What the physics actually offers you is a structure that exists without cause, without operator, without narration, and without anything outside it to have made it. The honest version is more unsettling than the fringe version. That is usually how it goes. So do not reach for an author here. There is no author in this analogy. The structure does not need to have been written. It needs only to be. And because I have just spent several minutes taking things away from you, let me hand you the one legitimate exit properly, because it exists and you are entitled to know about it. There are two respectable alternatives to the block, and neither of them is stupid. The first is called presentism, and it is what you believed before you started watching this. Only the present moment is real. The past has ceased to exist. The future does not yet. It matches your experience perfectly, which is a genuine point in its favour, because experience is data. Its problem is that it needs a universal present, one true now shared by the whole universe. And relativity has no room for one unless you add something to the theory that no experiment has ever detected. Presentism is not refuted. It is expensive. The second is called the growing block, first laid out by the philosopher C.D. Broad in 1923, and it is the one most people actually want when they think about it. The past and present are real. The future is not. Reality accumulates. Things genuinely come into being. It keeps the open future, which is the thing everybody is really trying to protect. It has presentism's problem. It still needs an objective edge, and it has one all its own, which I find quietly horrifying. On the growing block, you have no way of telling whether you're at the leading edge or somewhere back in the accumulated past. Your experience would be identical either way. Every moment of your life, including all the ones you think are finished, contains a version of you convinced it is happening now. So even the comforting option has a trapdoor in it, which leaves you with something narrow. I know it is narrow. I would not insult you by pretending it is more, but narrow is not nothing, and I want to name the one thing that is genuinely there, because I think it is real, and I think it matters. What you are feeling when you feel that somebody is gone is not a feature of the universe. It is a feature of your position in it. Grief, described in the language of the geometry, is the experience of occupying a region of the structure that no longer includes them, while other regions of the same structure still do. The absence is local. It is absolutely real. I'm not going to do the thing where a physics fact is used to tell somebody their pain is a misunderstanding, because it is not, but it is local. It is about where you are standing, and in the only sense that the equations recognize, they have not been deleted. Nothing is ever deleted. There is no mechanism in the mathematics for removal. That is the whole of it. It is small, and it is cold, and it is true, and it is more than most of what gets said in that room. Now I have to take you somewhere harder, because everything I have just said about them applies to you as well. Part 12. The page is already bound. The choice you're about to make, whether to keep listening to this, what to say to somebody tomorrow, who to forgive before it stops being possible, is already a feature of the structure. I want to walk into that carefully, rather than just dropping it, because it is the part people find hardest, and it is also the part that is most often overstated. Here is the technical situation. The equations of general relativity are deterministic in the strict mathematical sense. Give me a complete description of one slice of space-time. Everything, everywhere, at once, and the entire past and the entire future are fixed by it. This is not a controversial claim. It is what the theory is. The four-dimensional object does not get amended. Nothing is added to it. There is no process by which a region that was one way becomes another way, because becomes is a word that requires time to be a thing that passes, and we have spent 2 hours establishing that it is not. So why does it feel like choosing? Because of what a version of you at any given set of coordinates actually contains. It contains records of earlier regions, memories, and it contains no records of later ones. That asymmetry is not arbitrary. It comes straight out of the entropy gradient we talked about, because forming a record is itself a process that increases disorder, and it can only run one way. So every version of you, everywhere in the structure, finds itself with a settled past behind it and an unsettled future ahead of it, and describes the difference as motion, and describes the unsettledness as freedom. The uncertainty is completely real. It is a real feature of you. It is not a feature of the block. Now, the standard response to this among physicists is a philosophical position called compatibilism, and I want to give it its full strength before I say the honest thing about it, because it is not a cheap move and it is held by very thoughtful people. Jim Al-Khalili is among the physicists who have defended a version of it publicly. Compatibilism says this: what you actually want when you say you want free will is not the ability to violate physics. Nobody wants that. It would be terrifying. What you want is for your actions to come from you, from your reasoning, your values, your history, your character, rather than being imposed on you from outside. And on the block they do. Nothing overrides you, nothing bypasses you. The decision you make tomorrow is made by the process that is you, thinking it through, weighing it up, and arriving somewhere. That the whole thing is also a fixed feature of a four-dimensional object does not remove you from the causal chain. You are the causal chain. Your choices are not being made in spite of you, they are being made of you. That is a real position, it is coherent, and a great many careful people find it sufficient. Here is the honest thing about it. It works by redefining the word. It is not a rescue of what you meant when you used the phrase free will before you started watching this. What you meant, what everybody means before philosophy gets involved, was that at the moment of deciding more than one thing could actually happen, that the future genuinely branched at you. Compatibilism does not give you that. It cannot. It gives you a different thing, calls it by the same name, and points out correctly that the different thing is the part you actually needed. I am not saying that is wrong. I think it might well be the best available answer. I am saying that a word was quietly redefined and you were not sent a memo, which, if you have been paying attention for the last 2 hours, is a pattern you have now seen 4 or 5 times. And before we leave this, there is one obvious escape route that people reach for, and I should close it, because it seems promising for about 30 seconds. Quantum mechanics is random. Surely that saves us. If the world at the bottom is genuinely indeterminate, if the electron really does not have a decided answer until it is measured, then the future cannot be fixed, and the block cannot be complete, and there is room after all. There are 2 problems with that, and the first one is simply that randomness is not freedom. A coin flipped inside your skull is not you deciding. If your choices are settled by quantum noise rather than by a fixed structure, you have not gained authorship. You have swapped a determined author for no author at all. Nobody who wants free will want that when they look at it closely. The second problem is more interesting, and it is that the determinism might survive anyway. There is a minority position in the foundations of quantum mechanics called superdeterminism, held by people including Gerard de Hooft, a Nobel laureate, and Sabine Hossenfelder. It says that the apparent randomness is not fundamental, and that the reason quantum experiments look so strange is that the settings of the measuring devices and the systems being measured share a common past and are therefore correlated. It is unpopular. Most physicists find it distasteful, and it has never been refuted because it cannot be. The assumption it denies is the assumption every experimental test has to make in order to be a test at all. Experimenters have tried to close that door as far as it can be closed. There is a beautiful set of experiments from the last decade in which the settings of the detectors were chosen not by a computer and not by a person, but by the colour of light arriving from quasars billions of light years away. Light that left before the Earth existed, so that any conspiracy correlating the settings with the particles would have had to be arranged before the solar system formed. The experiments came out the way quantum mechanics said they would, and superdeterminism technically is still standing, because you cannot rule out a conspiracy by pushing it further back, you can only make it more extravagant. So, let me give you the image, at full size, because we have been building it since part 2. There is a book on a shelf, a thick one, 1,000 pages, cloth-bound, closed. It is not being read. Nobody is in the room. Page 1 exists. Page 1000 exists. The page where the protagonist is born exists, and so does the page where the protagonist dies, and so does every page in between, and every one of them is equally there. The book is not more real at the front than at the back. Reading it adds nothing to it. Closing it removes nothing. All of it is bound into one object and has been since it was made. Now, you are a character in the book. When the reading is at page 247, that page feels like now to you. The pages before it feel like memory, solid, settled, done. The pages after it feel like uncertainty, like possibility, like the parts that have not been decided. And every single one of those feelings is an artifact of being inside the story rather than a fact about the book. From outside, from the perspective of the closed volume sitting in the quiet, there is no special page. There is no page that is happening. There is just the book. And here is where the image turns, and I need you to follow it all the way, because the comforting version of this metaphor is not the true one. You are not the reader. There is no reader. There is nobody holding it. There is no finger moving down the page and no light falling on one line at a time, because a light moving down a page would be a thing happening in time, and there is no time outside the book for it to happen in. Nothing is being read. Nothing is being played. There is no author either. Do not reach for one. The structure does not need to have been written. It needs only to be. The page of your death is on that shelf. It is not waiting to be written. It is not a blank that will be filled in when you get there. It is bound into the same volume as the page you are currently on, made of the same paper, as finished as page 1. Somewhere in the structure, you are 7 years old, and you are afraid of something specific in a specific room, on a specific evening, and nobody has come yet. That version of you is at its coordinates. It did not stop. It is not a memory that you are carrying. It is a region, and you are elsewhere in the object from it. Somewhere in the structure, you are saying goodbye to somebody you have not met yet. Somewhere in the structure, the last thing that is going to happen to you is happening. Not in the future, not later. In a part of the object you cannot see from where you are standing, for the same reason that you cannot see Paris from your kitchen. And the version of you that woke up this morning, that opened its eyes, and lay there for a moment before getting up, that one is still there, still opening its eyes, permanently, not as memory, as geometry. Now, I am not going to tell you how to feel about that, and I want to be explicit about why, because I think the refusal is the most honest thing in this entire video. There is a version of this where I tell you it is beautiful, that nothing is lost, that everyone you love is permanent, that your best day is still occurring and always will be. And there is a version where I tell you it is horrifying, that you are a fixed shape, that nothing you do is chosen, that your worst hour is also permanent and also always occurring. Both of those are available. Both of them are things people genuinely believe after encountering this, and the physics does not choose between them. There is nothing in the geometry that says which reaction is correct, because the geometry is not the kind of thing that has opinions. It tells you what is there. It is silent about what to do with that, and if I pretended otherwise, if I sold you the comfort or sold you the dread, I would be doing exactly what this entire video has been about. I would be taking something enormous and handing it to you in a smaller shape, because the smaller shape is easier to carry. So here is the last thing about the structure, and then we go to the only question left. You're not one person moving through a life. That was never what was happening. You're a 4-dimensional shape, threaded through the block from one end of yourself to the other, and every cross-section of that shape, every slice at every set of coordinates, is a moment of you, the infant, the 7-year-old in the dark room, whoever you were at 19, this one, listening, the last one. The shape does not move. The shape is. Which brings us back, finally, to the question I asked you at the beginning, and have refused to answer for 2 hours. All of this has been sitting in the open since 1908. Not one line of it is secret, so why has nobody ever told you? Part 13. Why nobody ever told you. There are 3 answers, and I have come to think that all 3 are true at once, which is the least satisfying possible outcome, and also, I suspect, the correct one. The first answer is the dullest, and it is the largest. The plain sentence has no use. Physics is a machine for making predictions, and it is rewarded, with funding, with citations, with careers, with prizes, almost exclusively for making them. And the statement "the future already exists" does not predict anything. It does not move a decimal place. It does not tell you where the satellite will be, or what the collider will see, or how the star will collapse. You can do every calculation in relativity perfectly for an entire career and never once have to decide whether you believe it. It is, in the most literal professional sense, optional, and optional things get left out. Not once, dramatically, by somebody. Every time, by everybody, in every lecture, in the ordinary course of running out of the hour. A physicist teaching special relativity has 90 minutes and a syllabus, and the Lorentz transformations are on the exam, and the metaphysics is not. So it goes. And it goes again the next term. And the students who sat in that room become the people teaching it, and they teach what they were taught, and the omission propagates with perfect fidelity down 100 years because there was never a moment where anybody had to decide to omit it. That is answer 1, and it accounts for most of it. It is not sinister. It is worse than sinister. It is administrative. The second answer is the one we spent the middle of this video establishing, and it is that saying it plainly has a price, and the price is visible in the record. Bergson said, at least, that the question was real and that physics had not answered it, and he lost his standing in science permanently and is remembered by physicists when he is remembered as the man who got the twin paradox wrong. Gödel said it in the most rigorous form anyone ever has, and physics kept the mathematics and quietly discarded the argument, and the essay he actually cared about is not taught anywhere. Barber said it, and it cost him 30 years, a career, an institution, and a salary, and he was in his 60s before the book existed. Ravelli said it plainly, beautifully to a mass audience in this century, and the curriculum did not move. People notice these things. Nobody has to be threatened. A young researcher watching that record does not need to be told what happens to people who spend their time on unfalsifiable foundational claims. They can see it, and they choose, sensibly, to work on something else, and that choice is made independently by thousands of people, and the aggregate of all those sensible individual choices is a silence that looks exactly like a policy and is not one. And then there is the third answer, and this is the one I have been turning over since I started working on this, and I do not entirely know what to do with it. It is possible that the silence has been a mercy. Consider what it would actually mean for a species to fully internalize this. Not to know it as a fact. You have known it as a fact for about 2 hours now, and you seem to be functioning. But to feel it, continuously, the way you currently feel that the future is open, to have the page of your death sitting in your peripheral vision every waking moment, as present and as settled as your own hands, to reach for a decision and feel it already made, to grieve and know precisely, structurally, that the person is at their coordinates and that nothing whatsoever can be done with that. I am not sure a person could raise children like that. I am not sure they could make breakfast. The illusion of flow may be the thing that permits all of it, the planning, the effort, the hope, the specific and necessary belief that tomorrow is not yet decided, and that what you do this afternoon might tip it. Strip that out completely, and I do not know what is left that could get up in the morning. And look at the word Einstein chose. He did not write that the distinction between past, present, and future is a mistaken illusion, or a foolish one, or a naive one. He wrote that it is a stubbornly persistent illusion. Stubborn, as in, it does not yield. As in, you can know the whole of what I have told you tonight perfectly, and go and stand at a window and still feel time moving past you like water, because the illusion is not a belief you hold. It is a piece of equipment you are made of, and it does not switch off when you understand it. Maybe it has to be stubborn. Maybe a mind that could shed it would not be a mind that survives. So there is your answer. It has no professional use, so it does not get taught. It has a personal cost, so it does not get said. And it may be that a species that fully absorbed it would stop working, so nobody has felt much urgency about pushing. They called it a problem. They could have called it a result. And that one word, repeated, unexamined, across 100 years and 10,000 lecture halls and every popular book on the subject, is the whole mechanism. Not a conspiracy, a vocabulary. But I want to refuse the third answer even as I offer it to you, because it is the most comfortable of the three, and comfort is what got us here. It is still an illusion. However kind the silence has been, however necessary, however load-bearing, the thing it protected you from is true, and it was true this whole time, and it will be true after this video ends. You were not told, with the clarity it deserved, by the people who knew. Not because they were cruel, because it was nobody's job, and it never paid, and it cost the people who tried. You know now. And if you want to see the shape of it for yourself without taking my word for anything, the experiment is free. Find a physicist, not on a stage, in a kitchen, at a party, somewhere they are not performing. Ask them whether Einstein meant what he wrote to the Besso family. Ask whether the Wheeler-DeWitt equation really has no time in it. Ask whether the future is, in the technical sense their own equations imply, already there. Watch their face. You will get the pause. You will get the careful sentence. You will get the word well, and the small smile and the change of subject. That gap between what they can prove and what they are willing to say out loud in front of you is the entire subject of tonight. So here is the last thing. Right now, you are walking towards something, a conversation, a meal, a morning that is years from here. Whatever it is, you can feel yourself approaching it. You can feel the distance closing. You can feel time carrying you toward it whether you want to go or not. And that sensation is so total and so constant that calling it an illusion sounds almost like a joke. You're not moving toward it. You are already there. You have always been there. The page is bound into the volume, and the volume is complete, and the only thing that ever changes is which part of yourself you can currently read. You're not moving toward your future. You're reading it.